In today's lesson, we are going to see the inheritance applied to gaming. Okay, in the case that you don't have the code of the previous lesson, just download it from this link. Okay, and you can continue after you have downloaded and open it the project. What we are going to see today is the most basic example of inheritance applied to gaming, and this would be the most basic example. The example of hierarchy for classifying what is a player, an enemy, and an NPC. Okay, so we would have as a base class the class avatar. Okay, the class avatar will contain both the properties and the methods that share in common all these three elements: the player, enemy, and NPC. So we have a private member that keeps the state of the avatar, a private member that keeps the life, and a private member that it's the speed of movements of this avatar. And as the methods, we have the method decrease life, the method increase life, and the method move. Okay, also these three methods are going to be used by all of the classes who inherit from avatar. In the case player, I have defined two properties: the property coins, okay, and the property bullets. And as a methods, I have identified so far a method increase coins and a method shoot. For the case of the enemy, we can identify its initial position, a value of the damage it can apply to the player, and a detection range, that it's a range that the enemy detects the player. As a method of the enemy, I have defined the detect player, the method attack player, and the method return to idle state. As for the case of the NPC, so far I have defined it as a property, the property of the dialogue. It's the words that the NPC is going to say to the player, and as a method, the method talk, that it's the action that will allow the NPC to communicate with the player. Okay, before going into game programming, what we are going to do first is we are going to organize a little bit our project in order to grow in a more cleaner and structured way. So we are going to the project, okay, and for the case of the game scene, we are going to apply this structure. Okay, so what we are going to do is our game objects, we are going to rename it as level, okay, and we are going to create a new empty game object, okay, that we will call it as objects. And inside these objects, we are going to move both the portals, the spikes, and the coins. Okay, so we move all three to objects. Okay, we are going to move the floor also to the level, and we are going to create another game object that we will call statics, where we will place the 3D objects that make the static layout of the level. Okay, the last thing that we need to add is an empty game object called avatars, where we will place the NPCs and the enemies. Next, we are going to reorganize a little bit our scripts folder. Okay, so we go to our scripts folder, and we are going to create two new folders. A folder called objects, okay, where we will place the coin, the portal, and the spikes, and we will create a folder called avatars, where we will place the script player. As for the rest of the scripts, what we are going to do is just in the assets folder, we are going to create a new folder called exercises, okay? And in this folder exercises, we are going to move anything that it's not game related. So that is these scripts, okay? We are going to move them in exercise. Also try to create another structure in exercise with the scripts, moving the scripts right there with a folder called scenes, and we will move the scenes bucles and sample scene to that newly created scenes folder, okay? And in related to the others, for example, we have this image that belongs to the exercises that we can create here, okay? We can create a folder resources, and we can move the image of here to resources, and anything related to that to the exercises should be right now on this folder, okay? The prefabs, this belongs to the exercises, so the resources prefabs like this, and plugins we can leave it right there because it's our library for Twin, and this is something that we might use in the future, okay? And the last thing that we have to do is on the same folder we are going to create a folder called game, where we will place resources, scenes, and scripts, because we have already filtered that only here are scripts and resources only related for the games, and in the resources more of the same things that are only related to the game, okay? Just to make sure that everything is fine, just load the game scene and check that it behaves as it should, okay? So if we collide with the element, we get our life decrease, and if we collide with the portals, we get our life increase, okay? And if we collide with the coin, we destroy it and we increase the number of coins that we have, okay? So this scene works. Let's check the exercises. Let's check the bucles scene, okay? Okay, the bucles scene is there, it's working fine, good. And the sample scene, it's also working, okay? So everything is working fine. So we load the game scene and we can move forward. So the first step will be to create the script avatar, okay? And we will set that the player will inherit from it, okay? So let's go back to the code, and we are going to create the script avatar in the folder scripts avatars, okay? So go to the project, and in scripts avatars we are going to create the script avatar, we are going to open it, and we are going to do is that player inherits from avatar. Next we are going to start to move some logic from player to avatar, okay? So we are going to move first the logic of life. So we are going to move life to avatar, and remember that we need to change from private to protected in order for the classes who inherit from avatar to have access to the private member variables and private protected methods. Okay, so we get all related with life, so increase life and decrease life. And we can keep it public for the moment. It works both protected and public, so we can keep it public, the increase life and decrease life. And next we would take the on trigger enter, and we would move it in the avatar class. Let's take this opportunity that the logic of coin shouldn't be in avatar. It's something that should be in player, just to use what we learned in the previous lesson related to the virtualization of methods in order to be able to extend its behavior. So what we are going to do is we are going to change from private to protected, and we are going to use the virtual instruction in order to be able to extend this behavior inside player. So what we would have in player would be, let's copy paste that we would go faster. Okay, so what we will have here is that we are going to override, okay, and the logic of spikes and portals is something that we are inheriting from avatar. It's something, the logic of spikes and portal, it's something that it will apply to all three elements, the player, the NPC and the enemy, and it should be at this level. But the logic related to collecting coins is going to be something only related to the player. Okay, so right now we are extending the functionality on trigger for the player, and here we call to the base on trigger enter. Okay, and what would happen here is that when there is collision with the player, it's called this one, then it's called the base of the inherited class. We can go to the definition, and in the avatar it would run the code related to the collision to the spikes and with the portal. Okay, after running the logic of that, then a logic that it's only for the player, the coin collision, will be executed. Okay, so if we save and run the project, we should have the original behavior. Okay, so we go to the spikes, we collide the spikes just to notice that our life is decreased. Okay, that's good. And we go to the portals to notice that our life is increased. Okay, and finally we should be able to collect the coins. 1 coin, 2 coins, 3 coins, and the coins get destroyed. Okay, so right now we have used inheritance just to get the collision with the spikes and portal in the avatar, something that other elements who inherit from avatar are going to also take advantage. And we have extended that behavior in order to consider that the player is going to collide with the coins, so he has to collect the coin and destroy it. Now the next step that we are going to do is we are going to create the two scripts, NPC and enemy, that will inherit from avatar. Okay, we will create it on the scripts folder. Okay, so let's go to the codes. Okay, so here we would create NPC, and we will make that it inherits from avatar, and we would create the script enemy that it also inherits from avatar. Okay, now let's go back to the Unity editor, and here we are going to create a couple of game objects that will be our NPC and an enemy. Okay, so in the scene we are going to create a couple of game objects. Let's use capsules. So we have this capsule here that we will call it enemy, and for the moment we can duplicate by Ctrl D the game object, and we create the NPC. Okay, what we are going to do to differentiate between these two is that we are going to assign different colors. So let's create a couple of images that we will apply as a texture for these two elements. So we can go here and we can just for example copy paste this one and call it red, and we would open it. We just use a plain color. In this case we would use red, and since we don't need an image so large, we can just rescale it to a really small size. Okay, square one, but it doesn't matter in this case. Okay, so we have our red color, and now that we are here, we are going to do the green color, and save it as green. Okay, now back to the editor. We have our two colors, and we can drag and drop on the elements on the scene, in the enemy and in the NPC. Okay, the next thing we need to do, first we need to add them a rigid body, so they are included in the physics. And now we can assign the scripts, the script enemy and the script NPC. Okay, so now the first test, just to check that everything is working fine, we are going to add two debug log messages that will be shown in the execution, just to know that the script has been attached successfully and they are running the start method. Okay, so in the case of the enemy we can use debug log, and for the NPC we would do a similar message, NPC has been initialized. Okay, so now if we go back to the editor and we run our scene, we should have the two log messages displayed in the console. Okay, so as you can see, the NPC has been initialized and the enemy has been initialized. Okay, we got these two elements right there. For the next step, what we are going to do is that we are going to create a public member variable that we can use in the Unity inspector to set the life of the elements of the player, of the NPC and the enemy. We want to be able to set its initial life. Okay, and in order to do it, what we are going to do is in the script avatar we are going to create a public member variable that we will call initial life, and that value, we will use that value to initialize our private member variable mlife with initial life. Okay, so let's go to the code, and in the avatar we create a public integer initial life, and we will assign a default value of 100. Okay, and what we would do next, that in the start method we assign life to the value of initial life. The next thing that we are going to do is on the method on trigger enter, we are going to change the debug messages. Okay, so let's go back to the code and replace the debug log message on the spikes and also on the portal. Okay, so what we are doing here is that now aside from a custom message for each case, spikes and portal, we are including what's the name of the game object that avatar is attached to. Okay, so when the player or the enemy or the NPC collides with the spikes or the portal, what we are going to get is the name of that game object plus this message: spikes for spikes, portal for portal. Okay, now let's go back to the scene, and for both enemy and NPC we are going to freeze the rotation. In the constraints we are going to freeze the rotation for the X and Z axis. That way the object is not going to fall, and we are going to make sure that both elements are close to the player, because what we are going to do right now is just to use the player to push both game objects to the spikes, just to check that the behavior on trigger enter, that it's inherited by enemy and NPC. So this logic of on trigger enter is called for both for NPC and enemy. One thing that I have missed is that aside from displaying a custom debug log message to know that what's the game object who has collided with the spikes, we are going also to do the same for the methods increase and decrease life. We are going to add the name of the game object that is applied to increase and decrease life, in order to know just that who is applying the methods increase and decrease life. Okay, so here we will have decrease life and here increase life. Okay, so the flow would be first the trigger enter for any of the three elements: the player, the NPC and the enemy, and if they collide with either spikes or portal, with the spikes, they will decrease life. They will go right here, and the backlog message displaying the name of the game object will be displayed in the log message with the amount of life left for that game object. Okay, so now we can go to the Unity editor, press play. Okay, and now we are going to push both elements just to trigger this logic, the logic of on trigger enter, and just to check that everything is working as expected. Okay, let's clean the log just to start fresh, and as you can see, I have pushed the NPC enough to collide with the spikes, and as you can see in the log message, we have the first log message that was this one. Okay, on trigger enter has been called. It has been detected that it has collided with the spikes. The debug log message is there, and next it would be called the decrease life, and decrease life will decrease life and display the name of the game object plus the current life. So what we have in here is just that, the message of collision and the message of decreasing the life. Let's do the same for the enemy. Let's push it to the spikes. Okay, a little bit more, and that's it. Okay, so here we have the same. Enemy has collided. Enemy is the name of the game object, and enemy decreased life to 90. Okay, so both enemy and NPC are inheriting from avatar the behavior of on trigger enter, and are just decreasing or increasing the life when they collide either with spikes or a portal. We are going to keep stressing out the concept of inheritance, the concept of extending functionality, okay, as we have seen with the case of the on trigger enter. This time we are going to extend the functionality of both enemy and NPC for the case of decreased life. What our goal is that in these two particular classes we are going to do some extra actions aside from the ones that we are already inheriting from avatar. Okay, in the case of the enemy, when the enemy dies, we are going to increase the player score, but when the NPC dies, we will decrease that player score. These are two different actions that will happen on decreased life when both of elements die. Okay, so what we are going to do, we are going first to create a public member variable. Okay, in the player script we will call our public member variable score. So let's go back to the code, and in the script avatar, for the method the decrease life, we're interested that this method can be extended in both enemy and NPC. So in order to do it, we should convert it to virtual. Okay, and now we can proceed to extend it. Okay, so we can go, for example, let's start with enemy, and we would be able to extend the behavior just by using override, and we need to call the base class, that means base decrease life. That way we are using the logic of that we are inheriting from avatar. Okay, and just right here we will place the code only related to the enemy that will increase the player score. Okay, we are going to implement the code next, but before of that we are going also to use the creaseLife for the NPC. In the same way, we are overriding the creaseLife, we are calling to the base functionality, and here we will decrease the player's score. Okay, now let's create the public variable member score on the player script. Okay, so we add it just right here. And as an exercise, what you should do now is that you have to check if the enemy life is 0. You have to do two actions. The first action is to increase the player's score. Okay, and the second action is to destroy the enemy, the current enemy. Okay, in order to do that, as a tip, I will tell you that a way just to get the player is through GameObject, the method fineObjectOfType, that will allow us to look into our scene for the GameObject who has attached the component player. Okay, and that will return that component, the player. Okay, so this will return the game player. Okay, and once we have the reference to the game player, we would be able to use it to access to, in this case, the score. Okay, so now what you are going to do is first check that the life is 0, and when is 0, you are going to get the reference like this to the game player, just to increase the score. Okay, and the next thing that you need to do is to destroy that same enemy. Okay, about how to destroy a game object, we have already done it in the case of coin, so please check that to find out how you can destroy the game object, and just go ahead and do it. Okay, the solution should look similar to this. First of all, we have used the if instruction to check if the life is below or equals to 0. Okay, if that's the case, then this code we are getting the player by finding it in the scene, and once we have the reference to that player, we can access to its public member variable score to increase it by a value we decide. This can be the value you want, no preference in that. And finally, we are calling the method destroy of the game object in order to destroy the game object who is attached to this enemy. Okay, next we are going to do exactly the same for the NPC. We are going to do some custom actions, but instead of increasing the player's score, we are going to decrease it. Okay, just do it. And the solution should look like this. It's exactly the same, but instead of increasing the score, we are decreasing it. Okay, so now that we have changed both for enemy and NPC, we have extended the decrease life method that we were inheriting from Avatar. Now we can proceed to test it. Okay, but before the test, in order to check that we are destroying both game objects, since they both start with an initial life of 10, for the moment we are going to just change the damage value on the spikes to, for example, 100. So when any of these two objects collides with any of these spikes, since its initial life it's 100 and the damage applied by the spikes is 100, so the first time they collide they would be destroyed. Okay, this is one change that we do, and the other change that we are going to do is just to display the score. Okay, so for the moment we are going just to add a debug log message, just displaying the score. Current score after hitting an NPC would be this one. Okay, and we would place a similar message on the NPC, sorry, on the enemy, to check the score. Okay, so now we can run the project and see the results. Okay, so we are going just to get positive score, so we are going to push the enemy. Okay, let's push it, and a final push, okay, there. Okay, so we have here is we get the message of the base class decrease life. Sorry, the first one would be this message has collided with the spikes. The enemy has collided with the spikes. Next message would be enemy decrease life to 0. That it means that it calls the method and it decreases the life. But we are calling the method right here. So we are calling here, calling the base, that the base decreases the life, and now we are checking the life, that in this case is 0, and we are displaying this log message that we can see in the console, that the current score after hitting an enemy, the name of the enemy, is 10. Okay, so now let's going to do exactly the same for the NPC. Let's push it to the spikes, one little bit more. Okay, there. So we have exactly the same. The NPC inherits on trigger enter, it triggers on trigger enter, it collides with the spikes, it shows this first log message, it decreases the life, but since we have extended that method, it decreases the life here, it decreases the life here, and here we check the value of life, and if the value of life is below or equals to 0, then we decrease the life, and we show this message that it's the message that we are getting just right here. So before we got 10 points, and now we are subtracting another 10 points, so we got back to 0 points. Okay, maybe you remember that we added a public member variable, initial life, that we were going to use just to set an initial life value for mLife. But if we change this value through the inspector, that changes nothing. Can you think a reason why this is happening? Okay, let's go back to the code. Okay, so we had that we placed on avatar the initial life. Okay, and in the start method we were initializing mLife with the value of initial life. So in theory we should have been able to set a value here of different value, for example 10. That way we wouldn't have needed to modify the damage value of the spikes, because the lowest number of damage that had any of these spikes was 10. So only to modifying the initial life value of the enemy would have been enough in order to do the previous test. Okay, so why? Can someone think about the reason why mLife is not being changed if we change it right there? Okay, because we are using the initial life, we change the life, but it's not changing, it's staying to 100. What's going on here? Why is that happening? Just think a little bit about it, please. Okay, and the solution is that maybe you recall what we did on the exercise of the inheritance with that vehicles, especially with the extending the update method. This is exactly the same case. Void start, it's right now it's a private method right here. Okay, it's a private method, and the same way happens with this, that it's also a private method, and the priority is that enemy is going to call when it looks for the start method, it will look first for its private. If there is a private, okay, it will run that private method, and it will ignore well, in fact, this method is not inherited because it started as private, and as I told you, the private methods are not inherited by the classes who inherit from the avatar. Okay, so in order to we want that this specific behavior to inherited in the classes. Okay, so think about how we do it, please, and just code the solution. Okay, and the solution should look like this. We needed to convert it to virtual in order for the enemy and NPC to be able to extend it. Okay, and we are extending them both because for the moment we are just displaying a different message in the actions connected to this override. But maybe later on when we need to create more specific actions for each class, we are going to need to override for real, because some actions are going to be dependent only in the NPC and in the enemy. For the moment, we are just using different debug log messages, and we are calling to the start method that we are inheriting from avatar, and now now we are initializing the life with the public member variable life. Okay, so what we are going to do right now, we are going to restore the value we got in the spikes. So let's start here with maybe 10, 20, 30 and 40. Okay, and in the case of the enemy, we are going, for example, with 30 is enough, and in the case of the NPC, maybe with let's leave it in 10, since the lowest damage number of the spikes is going to be 10. The NPC, as soon as it touches a spikes, is going to be destroyed, but the enemy is going to need a couple of collisions to be able to destroy it. Okay, so now that we have set all the data in order, we can proceed to run the application. Okay, as we have said, the enemy has a value of 10, so when we made it. Okay, let's collide. Okay, so we got the debug log message here. The NPC has collided, the NPC decreased life to 0, and finally the current score after hitting NPC -10. Okay, so we got it right, and now it's time for the enemy. The enemy has a life of 30. Okay, so it will need a couple of collisions if I am not wrong. Okay, a little bit. Okay, we have one collision here, and we need another collision that it's, I think that 20 of damage is the next one, so we are going to try to reach another one. Okay, this is my life, that the life of the player that has decreased. We are not interested on that, but let me check if I can. Okay, that's it. So first of all, the enemy collided with these first spikes. These first spikes, if we select them right here, these first spikes have a value of damage of 10. And since the initial value of the enemy was 30, it decreased it only 10 points of life. But on the next spikes, that the damage value were 20, it decreased all the life of the enemy. And the logic of the decrease, this one was executed, and the enemy was destroyed. Okay, the next thing that we are going to do is we are going to keep moving functionality from player to the avatar class in order for any element who inherits from avatar can take advantage of. And we are going to do it with moving forward. Okay, so what we are going to do is on the script player, we are going to convert this code into a function. Okay, so let's call it private void move to position with vector3 increment as a parameter. Okay, and the increment will be added here. Okay, so this is the method that we want to abstract, in the sense that meaning that we are going to move this to avatar in order for anyone who inherits from avatar can benefit from this move to position. Okay, and here what we need is just to call, and as a parameter, forward plus lateral. So we get here the shift that it's going to be performed. Okay, and in the move position we apply this shift to the current position to get the final position where the rigid body component of the current transform is going to move to. Okay, okay, so we have converted the whole thing into a function, and we can proceed to move this function to the avatar, so anyone can use it to move. Okay, but we have here a problem, that is that this function is private, so in order for anyone else to benefit from it, we are going to convert it to protected. So now player can use it, player, NPC, avatar, all of them, they can use it. Next we are going to move our public member variable speed from player to avatar. Okay, because speed is a property that anyone who inherits from avatar should have. Okay, so we have our speed property here, we have move to position. So what we are going to do is we are going to include in the update method that belongs to both the NPC and the enemy scripts. so they can move in their forward direction. Okay, so just right now what you should do is, in the update method, you should do the necessary code. You should type the necessary code in order for to move both the enemy and the NPC in their forward director. You can get the forward director just by accessing the transform and the forward. This is the forward, and of course you have the method move to position that you should add the increment in order to move the whole transform. So go ahead and do it. Okay, and the code should look similar to this. We are getting the forward the way I told you, by accessing to the transform, getting the forward. We are multiplying by the speed, and we are adjusting by the fraction of the time that belongs to a frame. Okay, so we get the increment that must be done in this specific frame. So we can use our move to position method in order to move to that increment. Okay, and we have done exactly the same in the case of the NPC. Right now I don't know exactly the forward vector that where they are going to go. We are going to find out just right now. So if we press play, okay, let's see. They are moving forward, okay, in that direction. Okay, what we are going to do is we are going to place them just in front of the spikes, so they are going to cross through the spikes and they are going to collide with the spikes. So we are going just to move them just right here. Okay, and since the enemy has a value of 30, we are going to add a new layer of spikes. Okay, and in this new layer of spikes, this one is going to be okay, this one we are going to get 30, just to make sure that the enemy first collide. If it doesn't collide with the spikes of damage of 20, at the second time it collides, it will collide with someone that will decrease its life to 0. Okay, so now if we run it and observe what happens, the NPC is going to be destroyed just right now, and the enemy is crossing the spike of first the damage 10, and now it's crossing the damage 30. That okay, it's destroyed. Okay, so we get the behavior we wanted. What we wanted was to we move the move position from player to avatar, in order for all the elements who inherited from avatar to take advantage of. And in the update method of both enemy and NPC, we get the forward step that needs to be on that specific frame, and we use it to move forward. In the next part of this lesson, we are going to do the bullet implementation. Okay, so we are going to add a new class called bullet that will inherit from avatar, and this class will have two public variable members. It will have the public variable member damage as an integer, and the public variable member type that will define if the bullet is from a player or if the bullet is from an enemy. Okay, So first of all, what we are going to do is just to create these two public variable members. Okay, so we are going back to the code, and we are going to create let's create the class right here. And we can just copy paste an existing class and rename it as bullet. Okay. Next thing that we are going to do is just to rename the name of the class bullet, and we will implement the two public member variables. Okay. And the next thing that we will do is to implement this method. Okay, this method should. Okay, so we are going to the method should will take 3 parameters. The first parameter is the type of the bullet that will belong either to the player or to an enemy. The second parameter is the position where the bullet starts, and the third parameter is the direction is going to take the bullet. And here what we do is just initialize our variable type. Okay, with the type, we are accessing to this game object, to the property transform, and setting the position to the initial position that the bullet is going to start. And finally, we are setting that the forward vector of this game object is going to be the direction that is sent by parameter. The next step would be in the update method. We are going just to apply the movement to the bullet. To do that, we are going just to use the method we abstracted before, the move to position method, applying it with the forward vector, the speed, and the time delta time to adjust to a fraction of the time for each frame. So we are going to use that in the update. Okay, so in the update we would be accessing the inherited method move to position that belongs, as you can see here, it belongs to avatar, and it just takes the increment it's going to take. And the increment is calculated by getting the forward vector, that it will be the direction that is going to follow the bullet. Okay, it will take the speed, that it's also an inherited public variable member from avatar class. Okay, as you can see, it belongs to avatar, and the fraction that it belongs to a fraction of the time for each frame. So like this we would be able to move forward the bullet. Okay, next we are going back to the editor, and we are going to create the bullet. In order to create a bullet, we are going to just use a small sphere. So just create in the hierarchy, create a 3D object and select a sphere. Okay, make it smaller. For example, if the player size is like this, the bullet can be just a 10% of the size of it. So we can choose, for example, a 10%, 0.1, 0.1. Okay, so we have here a smaller sphere that we can use as a bullet. On the sphere collider component, we are going to set the isTrigger property to true. Okay, this will allow us that there will be a collision that will go through all the objects. Okay, in this case we are not looking for the bullet to bounce, just to go through all the objects, enemies, walls, any object. Okay, okay. To this game object, we are going to add a rigid body. Okay, a rigid body component. So add component. rigid body. And to this component, we are going to disable the gravity. Right now, we are not trying to make a realistic bullet, just an object that is going forward in a direction. Okay, so we are going to disable gravity. And we are going also to add the script we have just created. So the script bullet, we add it right here. Okay. For the moment, for the speed, we can use a value of maybe 50, and the damage, let's make it I don't know, maybe 20. For the type value is going to be assigned in the moment it's created the bullet, so we don't have to worry about it. Okay. And finally, what we are going to do is just to let's rename the game object to bullet. And we are going to create the prefab. In order to create the prefab, we are going to just drag the bullet into a new folder that we will call prefabs. Okay, so we create a new folder in game resources prefabs, and inside this folder we are going just to drag and drop the bullet right here, and we have converted this bullet into a prefab that we will be able to instantiate in runtime in the code. Okay, now next, just remove the bullet from here, because we already have it as a prefab right here. And what we are going to do just right now is just to use this prefab. So on the class player, we are going to instantiate this bullet prefab. Okay, and we are going to instantiate it when we press the spacebar. So we are going to shoot when we press the spacebar. So let's go back to the code. Okay, and right now we are going to create a new public member variable. Okay, in the player script, we are going to create a new public game object bullet. Okay, so what we are doing here is just to the declaration of a new public variable member that will link with the prefab, in order for the player to be able to instantiate this same prefab. So let's select the player, and you can see in the inspector that a new field has appeared just after the inherited members from avatar. And in bullet we are going to drag and drop, and we are setting this reference to the prefab. Okay, so next thing that we are going to do, we are going to create a new method. Okay, inside the player script that would be to shot bullet. Okay, and in this method, what should happen in this method is just the first step would be to check the input. Okay, for the spacebar being pressed. So when we have detected that the key pressed is the spacebar, we proceed to create an instance of this bullet. Okay. Once we have created the instance of this bullet, we access to the newly created instance, and we access to the component bullet of this newly created instance. And once we get the reference to the bullet, now we can use the method shot we previously did in when we were creating the bullet script. Okay, and the parameters that we are going to use would be these ones. We will create a constant that would be name type bullet player. Okay. For those of you that don't know what a constant is the constant is a value that cannot change. Okay, that's why it's called constant. And the declaration of it, we can do it just right now. Okay, let's do it. Let's go back to the code, and we can do it just right here. Let's create the constant. let's make it private, the name of the constant and the value that we can assign. Sorry, I forgot the type. Okay, so the type, it's just the same as the declaration of a variable, but we are adding this key code const. That means that this is a constant. This is a value that cannot be modified. Okay. Okay, so back to the exercise. What we are going to do, well, we are calling the method shot from the bullet, and we are passing the parameters of the type, the position. We are using the camera position, okay, and the direction. We will use also the camera direction, okay. And finally, this method shoot bullet would be on the player's update. So now the exercise is that you take all these steps and you implement them in your own project. Okay, so go for it. So you should have something similar to what I have done. That is, in the update, we are checking if we are pressing the spacebar. If we detect that we have pressed the spacebar, we proceed to call our method shootBullet. Our method shootBullet, what would do is to create an instance of our bullet prefab, okay? And we will get the reference to that instance right here. And from that instance, what we need is to get the component bullet, our script. Once we get the reference to our component bullet, the only thing left to do is to use the method we implemented on bullet, okay, the method shoot, that will provide the necessary parameters in order for the bullet to properly work. If everything goes right and we go back to the code and we proceed to press play, we should be able to shoot as soon as we press the spacebar. Okay. So the next step that we are going to do now is to check with what collides the bullet in order to perform the right actions. So what we are going to do is to check the method onTrigger of bullet, and we are going to display this debug message when this method onTrigger is being called. Okay, so we are going back to the code, and on bullet we are going to use the method onTrigger that is inherited from monoBehavior, okay, from monoBehavior, and we have it right here, and we are going to override it. Okay, so what we are going to do right now is just to override the whole thing, extend the whole thing, okay, and we are going just to display a log message right here, okay, just to know that we are colliding with something on the bullet. Okay, just put a little bit more information right here, bullet, okay. Okay, so we have override the onTrigger enter. So now when the bullet collides with something, this message will appear. So let's go and try it. Okay, so let's clean the console, and if we press spacebar, since the bullet has been created inside the same player, it's obvious that it's going to collide with the same player. That's why when we shoot the bullet, it's going to show that it's colliding with the player. But it's also going to collide if we shoot the bullet, and let's try to shoot in the coin. Okay, as you can see here, you can see that the bullet has collided with the coin. The same would happen. The enemy and NPC are being destroyed by this one, but the same could happen with for example, the portals. Okay, we get the message of the portal here, and with the spikes. Okay, let's see the spikes, if it collides with the spikes here. Okay, so we are detecting just right here that the bullet has collided with something. You may recall that when we were creating the bullet on the sphere collider, we have set the property isTrigger to true. As I said, this allows for the bullet to go through all the game objects without bouncing on them. Okay, and that's the reason why the method onTriggerEnter works. If this isTrigger property is set to false, this method right here wouldn't be called, because this method onTriggerEnter depends that this property is set to true. If this property is set to false, we need to use another method that we can inherit from monoBehavior. So in order to check the collision between two objects that their property isTrigger is set to false, we have the method onCollisionEnter inherited from monoBehavior. So what we are going to do now, we are going to test this method. Okay, so right now what I ask you to do is to go to the Unity editor to set the property of the prefab bullet to false, and we are going to implement this method in the bullet script. Okay, you can copy paste the whole thing. Okay, so what we have right now is that in this method, and now that we have disabled isTrigger, this one is going to be called. Okay, and what would happen is that as soon as it collides with something, it would be destroyed. Okay, so now we can proceed to test it. When you press the spacebar, you can see the log message is the one that belongs to onCollisionEnter and not onTriggerEnter, because right now we are not using the property isTrigger, so the method that it's called is this one. And after the debug log message is displayed, next the bullet would be destroyed. So now we are interested that the bullet is not destroyed as soon as it collides with the player. So in order for the bullet to be ignored by the player, we have this utility. Okay, you can copy paste the whole thing. Okay, in the moment that you shoot the bullet, we can use the utility of physics of Unity just to call this method ignore collision. And what allows us to do this method is to ignore the collision between two colliders. In this case, we are interested that both the collider of the bullet and the collider of the player ignore each other. Okay, so that's why we are calling physics, we are calling the method ignore collision, and we are getting the component of the same player. Okay, ignore this collider with the collider of the newly created bullet. The bullet, we get the component, we get the collider, and we tell the system please ignore this collider against this collider. So now if we go back to the project and play it, you should be able to shoot the bullet and the bullet won't be destroyed, okay, until it touches the floor or anything different from the player. That in that moment it would be destroyed, the bullet. Okay, right now just do the test of shooting the bullet and making it disappear against different objects. Okay, just coins, for example, or the spikes. Okay, or the portal, or even some static objects like this sphere. Okay, so feel free to test it against different objects like the floor. Okay, for the next step, that we are going to apply damage when the bullet collides either with the enemy or with the NPC. Okay, so back to the code. Okay, on the bullet script, on the method collision enter, we are going to check if the bullet collides either with the enemy or the NPC. Okay, so now take the lead and implement on collision enter for the bullet script. Okay, here you have to check if the bullet is colliding with either an enemy or an NPC. Okay, first, when you detect that you are colliding with either of these game objects, you are going to just show a debug log message, nothing else. So please go ahead and take as a reference the way we did it just for the avatar. Okay, so the way we did it for and trigger enter for the avatar, you are going to do the same for the bullet. Okay, so go ahead. Okay, if you have implemented the solution, it should look similar to this. What we are doing here is that on collision enter, we are detecting the collision of the bullet with some other collider. Okay, so we are getting the information from the collision, we are getting the game object collided, and from that game object we are checking if this object has the component either enemy or NPC. If it has the component enemy, it's colliding against an enemy. If it's getting the component NPC, it's colliding with the NPC. Okay, and after that we destroy the bullet. Okay, but before running the script, we are going to set the speed of both the enemy and the NPC to 0 in order for them to not to move and to be an easy target. Okay, so once you have done the change, you can proceed to press play. Okay, and now when you shoot the bullet, it should collide with either the NPC or the enemy, and it should display the debug log message that we have implemented. So let's do it. Let's shoot the enemy. Okay, and you have seen there that the message has appeared. Let's do it several times. Okay, so we get the collision right. Okay, so let's do it for the NPC. Okay, let's shoot the NPC. Okay, I have missed. Now I am hitting the NPC. Okay, so we are getting we are detecting the collision between the bullet and the NPC or an enemy. So the next step would be the final step to complete the logic of the bullet is to apply the damage to the collided avatar. So when you are detecting the collision with the enemy and the NPC, it will be called the method that we are already inheriting from Avatar, decrease life, that will allow us to decrease the life of both the enemy and the avatar. Okay, so now what you are going to do, back to the code, you are going to call the method decrease life once you got the reference to the enemy and the NPC. You are getting their public methods, and between their public methods, it's of course the method decrease life. So we will be able to, in this condition, we will be able to apply the decrease life into that particular element. Okay, so go ahead and just implement the whole thing. Okay, and the thing should look like this. We are getting the reference to the enemy, okay, and we are able to access the public method decrease life that enemy inherits from Avatar, okay, and we do the same. We do exactly the same for the NPC. We are accessing the decrease life, and we are able to decrease also the life of the NPC. So let's going to comment some of these debug log messages in order to display only the message when we call the decrease life, either for the enemy or for the NPC. We are interested to get the log displayed here. Okay, so what we are going to do is we can go to the Unity editor and play the scene. And now we can kill both enemy and the NPC. So let's do it. The bullet has a damage of 10, and the enemy had a life of 30, if I am not wrong, and the NPC had a life of 10. So let's increase a little bit the life of both the enemy and the NPC. Let's put it 100 for both and try again. Okay, so they will receive some bullets before they are destroyed. Okay, so they will receive at least 5 bullets, decrease to 80, 60, 40, 20, and the last bullet 0. So the enemy has been destroyed. Okay, it's the message of the enemy, the current score after hitting an enemy, and the enemy has been destroyed. Okay, we can do the same for the NPC. It requires also 5 bullets, 1, 2, 3, 4, and 5, and the NPC is also dead. Okay, just to summarize what we have done, we have implemented the class bullet. We have created the prefab bullet that we are using in the player class. When the player presses the space bar, the new bullet is created. The bullet is shot in the direction that the camera is facing, and the bullet ignores the same collider of the player in order not to collide with it. And in the bullet side, when it collides with either an enemy or an NPC, it proceeds to decrease the life of the enemy or the NPC. In this next part of the lesson, we are going to be introduced to the Unity UI. To be more specific, we are going to create just a text field where we will be able to display the current score. Okay, so Unity provides a collection of components that will allow you to create any kind of interface. We are going to start slow. by just displaying our score. And the first what we are going to do is let's go to the Unity project, and here we are going to create a new empty game object. Mouse right click, create empty, and this game object we will rename it to UI. Okay. Next, we are going to create a new object inside this empty game object that it's canvas. So right mouse click in the UI section, you are going to create a canvas. Okay. Okay. So inside the canvas, we will be able to place anything related to the displaying information through the Unity UI to the screen. Okay, so inside this canvas we are going to create the object test, and we are going to name it score. So inside the canvas, mouse right click, going to UI, and we are going to create a text field. Okay, in case that you haven't imported yet the Text Mesh Pro essentials, just import them. These are a collection of utilities that allow you to use different kind of text. Okay. Okay, so we have our text, and if we double click on it, okay, we are centered on it, and if we press 2D, okay, we are just watching the whole screen. So right now, if you just press play, the text is going to be placed just in the middle of the screen. Okay, so just a quick introduction of what's going on here. So we have created our empty game object. We have created the canvas game object that allows us to place elements in the screen, and we have created a text component where we will be able to put any information we want. Okay, and this text we can move it any way we want. Okay, we can first scale it as in a similar way that we were scaling any game object, and we can move it any place we want. Okay, so after moving it, if we press play, okay, the text field is now on this corner. Okay, so more information related to that. Is it possible that you are going to work in developing for mobile phones? Mobile phones and tablets used to have different resolutions, and Unity provides some utilities, some functionality in order to ease the process of developing for these different resolutions. All the elements that are inside the canvas have the component rectransform. This component allows to be able to align the text in many different ways. For example, this whole system allows to be able to align the text in different positions. Right now, the whole system makes that this text is aligned centered to this screen, but we have multiple positions. For example, in this case, let's imagine that this field we want to be anchored to the corner right upper. So we would choose this option. So we can change the resolution of the whole thing, and the field will align to the upper left corner. For example, this is free aspect. Let's change it to 16:9. Okay, and the text would have been aligned to this position. You can test another formats, 16:10, and multiple different resolutions. Okay, so the whole thing is aligned in relationship to that. Okay, so now that we have our text component, we can proceed to use it. So we are going back to the player script. Okay, and we are going to create a public member variable that will reference the previous created text field. So we can create, just after bullet, for example, a public text that will be called display score. If the compiler marks as red this text component type, in order to import the missing libraries, you have the shortcut I used to use, Control dot. If you press Control dot, it will appear a list of options that will allow you to include the library you are looking for. In this case, we are looking for the library related to the Unity UI. Is this one, using Unity UI, and you only have to press Enter to include the library right here. Okay, so right now the compiler error has disappeared, and we will be able to use it. Okay, so we have declared of our public text display score, and we are going to link it with the score we have created in our scene. Okay, so select the player. Notice that you have the display score right here, and you only have to drag and drop the text field. Okay, I made a mistake. This is not a text field, but a text mesh pro. So we are going to use that, the text mesh pro, that it's text mesh pro UI. Okay, just like this. Now again, Control dot, just to look for the right import of the library we are going to need to use this type. In this case, it's using temp pro. Okay, so we have included the library, and now we are able to use it. And now, yes, if we go to the Unity editor, now if we drag and drop the score on this area, we are referencing the text field in our screen. Okay, next we are going back to the script player, and in the start method we are going to just initialize the text field we have just created. How we can set the text inside that particular text field? The text component, okay, has the property text. As simple as that, we can assign some value in that area. And since we have the score right here, we can just assign the text on the display, just like accessing to the public integer. And you can convert an integer through this method. Okay, so just first of all do it, and let's test it just to get the score to 0. Okay, so play it, and just like this you would have get, as you can see, the score to 0. Okay, of course you can extend the whole thing, like specifying a score it's like this, equals to like this, and you don't need, in this particular case, just to convert it to a string, because when you are doing like this, the whole thing it's automatically converted to a string. So just do the test and play it again, and you would get score equals to 0. Okay, so we have seen how to set the text inside this text component. Okay, and the next thing that we are going to do, we are going to update the text every time the score changes. So go ahead and find out how to update this text component with the score when it changes. Okay, so just do it. Okay, and the solution should look like this. So for every frame in the update, for every frame that is executed, we are assigning the value of the text field to this value. So every time the score is changed, we are getting right there, and we are updating the whole text field. If we proceed to run it and kill some enemies, we get the score of 10, and if we proceed to kill the NPC, we are decreasing the score back to 0. Okay, so the score is being updated, but the main problem here is that it's being updated every frame. And you have to know that all the operations related to strings are the performance is a little bit expensive. So you should avoid to have to perform string operations every frame. So in order to just to minimize that, we have to find out just the right moment when the score has changed, just in that moment to update the text field. So we are not doing for every frame and with the cost that that means. Okay, but because you have to take into the consideration that maybe at this stage, of course it won't matter if you update it in the update, but when you have a large project with many things getting resources from the CPU, eventually you need all this all the CPU you can get. Okay, so how we are going to do that? We are going to replace the score, and we are going to replace it with this. Okay, we go back to the code, and for the score we can just replace it like this. Okay, so I don't know if you remember, but in the first lesson we saw the getters and setters as a way to provide to other classes to have access to some properties. Okay, and we are going to use this in order for to be able to detect the exact moment that the score has been changed. So in that right moment, we are only going to update the text in that specific moment. Okay, so first of all, delete the line right here just to make sure that this is working. Okay, and just run it. And if we proceed to kill the enemy, okay, let's see, and score of 10, and if we kill the NPC, back to the score of 0. So what's happened here? What's happened here is that this score is being accessed. Okay, if you press Shift F12, you are able to know who is using this variable. The only thing you have to do is just click on the variable or on the method. It works for almost all the elements, and press Shift and F12, and in here in this section you will get all the places where this variable is being used. Okay, so for example, in the enemy, when the enemy is destroyed, we access to the player, we access to that public variable getter. It's not a public member, but it's a getter. So since it's a getter, it goes through this path to set the value of the score. Okay, just like this, we are able to. Okay, so when we kill the enemy, we are increasing the score, so this code is going to be executed, the score is going to be updated, and in this right moment we can update the text field. Okay, so we are updating the text field just right here. Okay, for the sake of making more examples, just create some more enemies. Okay, so go back to the level and go back to the enemy, switch from 2D to 3D. Okay, and create some more enemies just to test the whole score system, that it works. For example, we will create another 2 enemies, and we will create another NPC. Okay, so with these elements, to duplicate an element, you have the option here to duplicate, or you have the option to press Ctrl D just to duplicate the selected game object right here. This will help you out to be more productive. Okay, so with multiple elements created, we can proceed to test the score system. Okay, so we can start killing some enemies. Okay, score 10, score 20, score 30, and killing the NPCs will decrease the score. Okay, minus 10 to 10, and finally back to 0. Okay, so in this section we have seen how the UI canvas system works. We have created an empty object, we have created the canvas, and in the canvas we have created this text field that we were going to display the score that has the player. And back in the code, what we have done is just to create a public member variable that reference this text field. Okay, and we have set that public member variable to the reference of the text field. Finally, on the code, we have made all the necessary changes, so when the score is modified, only in that particular moment the text field is also updated. Okay, we should avoid as much as possible string operations inside the update, because this is going to consume some resources that we may need later. Okay. Finally, as an optional exercise, I recommend you to do 2 exercises. That is, the first one would be to create another text display just to display the life of the player, and another text display just to display the number of bullets that the player has shot. Okay, these are 2 optional exercises. I am going to do it right now, so you have a reference of how to do it, but these are optional. You can get the final code of the project just from this link, so you have what has been done in this lesson. So this would be the necessary changes in order for the live to be displayed also in the screen. Okay, so right now we can proceed to press play. We are starting with a life of 100, and if we collide with the spikes, the life is decreased, it's updated, the text field, okay? And if we collide with the portals, the life would be increased, okay? 60 and 90. Okay, this is for the life, and now for the bullets shot. Okay, and this is the implementation to display the number of bullets that the player has shot in the screen. So if we proceed to press play and we start shooting, we are displaying the number of shots that has been made. Okay, these were the optional exercise. If you want to go further, just to display the number of collected coins or anything else, you are free to do it.